We're going to talk today about whether your mobile users are well connected. And the subtitle of this would be how to store and share data in the cloud from mobile devices. So I am Mandy Waite. I'm a developer advocate for the Google Cloud Platform. How many of you have heard of the Google Cloud Platform? All right, not many of you. Yes, you work for us. Okay, so we're not going to talk in a huge amount of depth about the Google Cloud Platform, because we're going to talk about something more specific. You can find me on Google Plus at +MandyWaite or on Twitter at TechGirl. And I will, hopefully, the hashtag and my Twitter handle will be on each of the slides. So the agenda, fairly straightforward. Why you really need to go mobile. How many of you are doing mobile development today? Okay, not so many of you. A few of you, okay. So next thing we'll be talking about building backends generally. We're not going to spend too much time on that. We're going to dive demonstrating to the main core part of the actual presentation, which is Firebase and how Firebase can help. And we'll look at some coding, look at authentication, offline mode, introduction, that kind of thing. Then we're going to be talking about going forward. What's next for Firebase, effectively? How many of you have heard of Firebase? Okay, not so many of you. Okay. Hopefully, by the time this presentation is finished, you'll know everything you need to know about getting started with Firebase. So, this is the marketing side. There's a couple of these marketing slides in there, but we really need to position mobile development now before we start talking about this solution, this Firebase, that I'm going to be talking about later. So, somebody came up with statistics that says that 2 billion people today have mobile devices. And somebody else came up with a statistic that by 2020, 80% of adults will have a smartphone. If you're doing mobile development, you know already that being constrained to the handset, having the application running exclusively on the handset with no backend is not a really good experience for the users. Then you can get the most out of your application if you have connectivity, backend connectivity. Then you can add features, enhance features such as social interaction. You can do gaming, you can do e-commerce, you can do in-app payments, that kind of thing. Over 50% of our Google Cloud Platform usage goes towards powering mobile applications. And we have a couple of really, really big customers that kind of account for much of that. And new business models are coming up every day. These are going to be enabled by things like sensors and the ubiquitous nature of mobile devices. Google has quite an extensive suite of tools for developers. Google Cloud Messaging, we have many, many public mobile APIs. We have Android stuff running on cars, on TV. We have wearables. How many of you have got a wearable, an Android wearable? Okay, not so many, not so big here yet. Okay, I haven't got one. I don't wear a watch. And phones, of course. On the cloud side of things, we have on the compute, we have App Engine, Google Compute Engine, and we have this new thing called Container Engine, which my colleague Brian Dorsey is going to be talking about tomorrow. So if you're interested in Docker and containers, go into Brian's talk tomorrow. And track 1, right? Yeah, it's in this track as well. Also, when it comes to storage, we have many storage options. We covered from NoSQL with the Cloud Data Store. We have SQL, and we also have an analytics tool called BigQuery, which can run analytics across massive data sets or even very, very small data sets. We have cloud endpoints for developing APIs. We're only going to touch on that very briefly today. And we have a thing called GitKit, which is an identity toolkit. And again, I'm not really going to touch on that today, but maybe for a future talk that would be really interesting. Also, on the business side of things, we have other services such as AdMob, mobile ads, Google Play services for Android, and also Google Analytics. So if you want to kind of analyze the interaction of users with your mobile device, you can use Google Analytics. Google Cloud Platform itself consists of a bunch of services. We've kind of mentioned some of them already, and I'm not going to go into detail on Google Cloud Platform today, but please check it out. It's very similar to other competing public cloud offerings, and it's good to go now. You can use it today, free trials, free trials available for Google Cloud Platform. So what's up with this building backends thing? So you can build backends today on Google Cloud Platform very straightforwardly. You have a client device. You effectively write some back-end application code. You can use this thing called Cloud Endpoints to expose your application code as an API. running on the same infrastructure that Google's APIs run on, things like Maps and YouTube. You can have that interacting with our cloud data store, storing and serving data within the data store, and you can wire up that to push notifications using Google Cloud Messaging or Apple APNS. And you have the whole virtuous circle here. You have storage from the device to the cloud, and you have notifications or updates to data being pushed out to mobile clients. So that requires some effort on your part on the back end. And really, the developer's guide to building backends is this: don't do it. Okay? You don't really want to spend your time developing server-side code, building backends, if you can avoid it. Now, you can't always avoid it, but it's nice to be able to get into a situation where you can, if possible. So that's why we're going to be talking about, well, I'll talk about Firebase shortly in a minute. So some of the challenges of mobile, and you probably, if you've done any kind of mobile development, you'll come across these already. You really want your applications to run on multiple platforms. You may start off with one specific platform, then expand out to others. Users generally expect updates in real time, particularly with the modern day applications that people have now. So chat-based applications are a good example of this, where you don't want to do something to be able to get updates to the data on the screen. You want it pushed out to you immediately. So when a chat message comes in from your friend, it will immediately appear, or you at least get a notification message saying there's a new message. So users are expecting updates in real time. Also, our devices run on a pretty unreliable network. My train journey to work, whenever I'm at work, and I'm not at work very often nowadays, from South England into London every day, I have probably 20% of the time connectivity. Most of the other 80% of the time I have nothing. So often the state of your application will be distributed across multiple devices and your servers. So you'll have some state in the servers and some state on the clients, some state not synced up to the servers and some state on the servers that's not been synced down to certain clients. And that comes and goes as the devices connect and disconnect from the network. So we have this distributed state of the application, which is an enormous challenge. Also, the large number of devices and the large number of iterations of your application run on those devices, you hope to be the next Snapchat, this is going to require massive scale. So we need to do all of these things, but we need to do them at scale. So it does sound scary, right? And so Firebase can help. So we're going to talk about Firebase in this section and pretty much for the rest of the talk. So if you're not here for Firebase, then you might want to go to a different track. But it will be interesting, I promise. So what is Firebase? And again, a few hands went up, a few people are familiar with it, so I guess it's still reasonably entrenched in the US, starting to get out into Europe now, into other locations. But Firebase effectively is an application platform that provides all of the common infrastructure that you need to build web and mobile clients. And it's broken up into three main areas, and I'm only going to talk about two today. So one of them we're not really going to get into, but it is pretty cool as well, and it might be worth checking out. So the first thing is Firebase is a real-time database. It effectively allows you to store and share data from client-side code. That's the first part. The next thing is user management. Now we all want to be able to authenticate users, identify users, and share data specifically for users. And Firebase provides all of the mechanisms, all of the toolkit that you need to be able to do authentication successfully. Now, if anybody's ever done authentication before in an application, you probably know how hard that can be. Next thing is hosting. And hosting in this context means that Firebase can host your application, your static web application. And it has full support for SSL, it has a CDN, and everything else that you need to host a static website. But we're not going to talk about that today, so just the first two items. So Firebase by the numbers. And just one bit of context here, so Firebase joined Google some weeks ago, 4 weeks ago now, I think, roughly. And we had a talk, a large event in San Francisco called Google Cloud Platform Live. And some of this presentation was run at that event, and they talked about some of the numbers. So these numbers are from that event, and they're reasonably accurate and reasonably up to date. So at that time, they had 117,000 plus, it could be 117,001, I'm not sure, registered developers. And at some point in the last 6 months, they blogged that they had They saw in their servers 1 million concurrent connections. So that's not recent, that was like 6 months ago, and they're still rising at quite a dramatic rate. So 1 million simultaneous devices connected simultaneously. I don't like these slides very much, but this gives you some kind of context into who's using Firebase today. So again, very large companies like Citrix and CBS, companies like Twitch and TED, the Nest API uses, or Nest actually leverages Firebase, and various other companies as well. So even good companies we choose to use Firebase. So back in the day, some years ago, and this has kind of gone backwards and forwards a little bit, the devices we had in our hands weren't particularly powerful. Clients were not particularly powerful. So we tended to move all of our processing over onto the server side. And all we would expect of the client was for it to render what we sent it. It could be HTML, it could be something else. We would expect the smart client to actually render what we sent it. But things have changed quite dramatically, and those devices that we have now are extremely powerful. And in fact, Jeff Atwood of Code and Horror posted 2 weeks ago a blog post that compared Apple devices over the years, from the iPhone 1 to the iPad Air 2, I think the iPad Air 2, and what we're seeing, what he was seeing effectively is that the iPad Air 2 is almost as powerful as his desktop machine today. So these devices that we have, I have my Nexus 5 here somewhere, are extremely powerful. We no longer need to do all of the processing on the server side. So what that gives us is our smart client plus Firebase, a client library, means we can push a lot of the processing work, a lot of the processing effort onto the client side, rather than just expecting the server to do all of this for us. And that makes an extremely powerful combination. So we have server-side, well, I'm going to talk more about this on the next slide, but we effectively have the ability to do a lot of stuff and store a lot of the stuff on the local device. And the ability to store on the local device is quite key to the concept of Firebase. So you have these things called client libraries. I'm going to go back to this slide. This client library effectively is what you write your application around. So it's, in some context, you'll find a client library will be a wrapper around an API, maybe a RESTful API, and effectively exposes the functionality of that API within a programming context. Maybe a library for Android, a library for Python, that kind of thing. So it very much simplifies the process of actually making calls out to an API. The client library in Firebase is a little bit more advanced than that, so we'll talk about that more as we go along. So the first thing that happens is we have our smart client and we have Firebase running in the cloud. And the smart client, via the client library, makes a persistent connection to Firebase. And we can talk about how this doesn't drain the battery later, because it only actually works, the persistent connection is only actually on when you're actually using the application that's actually accessing Firebase. Once the persistent connection is made, we can then start to synchronize data from the smart client, the application running on the device itself, to Firebase. And this is a two-way thing. Obviously, we can push data out to Firebase, and Firebase can push data down to us. So effectively, we have this two-way synchronization. And that's extremely powerful as well. But the power of this becomes even more apparent when you have multiple devices connected to your Firebase. And here we see 3 different devices. Updates from one device, or one application run on one device, will be pushed out to the Firebase. Then other applications running on those devices, or maybe the same application, would have registered an interest in updates to that data. So any client that was interested in that data would receive updates immediately from Firebase, in real time, effectively. And so updates on one device would immediately be available to updates on the other devices. And as you can see from the diagram, we have different devices here. We have iOS, we have Android, we have web clients. So Firebase supports many, many different types of clients. The database itself, the storage system behind Firebase, is NoSQL, and it stores JSON objects, nested JSON. So that kind of thing would be pretty much familiar to most of you already, doing any kind of development work. Storing JSON data in a NoSQL data store. Updates are pushed out in milliseconds when things change. So this gives you effectively real-time updates to data within your application. It also has a very, very simple security model. that gives you full control over the data access, who can access data, and also on validation of that data before it gets stored. And another really nice feature is that each piece of data is mapped to a URL. So you can actually access each piece of data that's stored in your data store, in your Firebase, via a URL, a RESTful call, or just in the browser. You can actually see it in the browser, and we'll look at that shortly. And we've kind of touched on this already. This is the second thing that we wanted to talk about when it came to Firebase. Firebase Authentication and User Management. So it has drop-in support for using email and password. Very, very easy to implement, but it also supports the four most common OAuth providers, such as Google, Facebook, Twitter, and GitHub. We have an example of GitHub coming up as well. If you need to connect to another authentication service, such as your own LDAP server, or maybe Active Directory, then you can use custom auth tokens as well. So they pretty much got you covered for everything when it comes to authentication. Common OAuth providers, fairly easy to implement, and also custom auth tokens and email and password if you choose to fall back to the lowest common denominator. So let's talk about coding. Coding is very simple as well, and we have some examples here. And I'm hoping that this is all visible to everybody at the back there. So we have some Java code, effectively Android code, and the way we get started with this is very simple. We just create a reference to our Firebase. Our Firebase is represented by a URL. In this case, we're saying your Firebase, but you would replace that with your name. We have Codemotion-demo today we're using. And that reference could be to your top level of your Firebase or to some lower level. You could be referencing an entity or a part of your JSON tree directly via this URL. And then, in order to actually access data, in this case we're going to set a value, we're going to say hello Codemotion, we can just call ref.child, and child being an immediate child of our reference. In this case that's the top level Firebase. And we call it record1, and we will set the value to be hello Codemotion. And that's it. That's all you have to do to store data. Now, notice one thing about this. You've not had to do anything on the server side other than sign up for Firebase and create a Firebase. You've not had to set up any servers. You've not had to implement any software stacks or write any server-side code. It's all available, all done for you. All you have to do is write to the client library that we provide. When it comes to storing data, it's not much different. Again, we're going to reference the child. Sorry, did I say storing? Reading data. We ref.child the record we're interested in, and we add a value event listener, and then we implement the methods of that value event listener. So when the data changes, and also on first time we actually call this, we will get the value back. So this will give us the value of hello Codemotion back immediately, the call to snapshot.get value, and any other subsequent changes to record1 will also be fired back to this method. So now we have a hook effectively onto that data, and we will get updates continuously whenever they change. A similar example written in JavaScript for those who are not interested in Android or writing web clients. It's very easy to do as well. Very, very similar. You'll see that what we've got for Java is very, very similar to what we have in JavaScript. In order to start talking to our Firebase, we create a reference. In this case, we're accessing the record1 component or child of the JSON tree directly, calling ref.set hello Codemotion, and then the next one we're reading the value back. Callback function takes in this value. Whenever the data is changed, the function is called, and in this case we're just logging the data out to the user interface or to a log file. We can also store objects as well. So in this case we're saying for the reference, set the value to be a JSON object. So we can actually extend our JSON tree very simply using JSON objects. Okay. When it comes to authentication and also going offline, we also have some special features as well. I'm going to talk about authentication first. Kind of already covered this already, so Google Plus, sign-in, Google sign-in, Facebook, Twitter, GitHub are all supported out of the box. Plus also email password and custom auth tokens. And we have an example for GitHub user authentication.
So the first thing to do, and this is pretty much the same process for all of the providers. The first thing you do is create an application. In this case, we go to github.com/settings/application and create a new application. And at that point, you have to register a callback. And the callback will be auth.firebase.com/v2, your Firebase name, /auth/github/callback. And there's a field in the GitHub dialog box that will allow you to put that in. That will be called whenever an authentication event occurs. And then in your code, very, very simply, you display the GitHub login pop-up as required when the user is not authenticated. So in this case, we're showing very, very simple code here. We have a reference to a Firebase, and we're calling in that ref auth with auth pop-up, GitHub being the auth provider we want to do, and a callback function. This is JavaScript, of course. A callback function, which ultimately will result in this auth data object being set. And the auth data object will contain all of the information we need to know about that authenticated user. That would include their email address, their name, anything that's naturally exposed by that authentication provider. So that's what we have to do authentication. Offline capabilities, we've already established that mobile applications not always on. They're not always connected to the network. Sometimes you're on an airplane and you actually have to physically turn them off, or nowadays put them into airplane mode. So that's a very, very common situation. And you want your application to carry on working exactly the same, whether it's offline or online. So one of the important parts of Firebase here is that we store much of the application data locally. So this client library is more than just a client library wrapping the API. It also implements storage, local storage on the device itself. So when you make a change, the first thing that happens is that data is stored locally, and all of the event triggers are fired for your application. So your application responds immediately as if that data has been stored in the Firebase. So your application will continue to respond. It will have its own local version of the data that might, of course, ultimately get out of date, but the application will continue to be responsive. When you're offline, you want other certain things to happen as well. The ability to detect presence. Now this is quite important as well. So if you're in a chat application, you're looking to see if your friends are online, they may have a green dot next to them or something else to indicate that they're online. That's quite easy to implement in Firebase as well. So each device will have this thing called .info/connected, something that we can actually register a call on to detect when that changes. So this goes on and off as the device comes on and offline. Not necessarily the application itself, but the call we've made to the actual Firebase from the authenticated application. We also have a presence reference here, the second one, which references something else within our Firebase, in this case presence/user ID. So this is specific for each user. What happens is we then set a callback function on the original reference, the Firebase reference, and that will be called whenever the status of info/connected changes. And we have this special function called onDisconnect, which effectively allows us to say what should happen whenever the device disconnects. And that will be to either remove our presence or change our presence status. So effectively all we're doing here is changing our status whenever we come and go offline. And that means we can do that kind of functionality where we have that option to say, yes, this user is offline, yes, this user is online. So let's drop into a demo. Again, it's quite small screen, so it may be a little bit clunky, but we'll see what we can do. And this is based on, we haven't quite put together a mobile demo for this yet. Ray's kindly put together this demo, which is using Polymer. How many of you are familiar with material design, Polymer? Okay, not so many of you, okay. You'll see what it looks like anyway. So this is our application. So I'm demonstrating how cool Firebase is, effectively. So this code is fairly simple code. It's a tutorial, Polymer tutorial. It's very easy to write. Some of the code that we have, wasn't there, isn't there now, is there. And we've effectively registered our Firebase. There's a Polymer component called Firebase Elements that does all of the hard work for us. So in this case, we haven't had to do much coding at all. We've effectively just wired up our Firebase using this Firebase Elements. We have one called Codemotion-demo. We have some other values here. We also had to iterate for our data in other places within the application. But apart from that, those changes, we've done very little to change the original tutorial application. So we go back to Chrome, and not that one. I want you. Right. So that's what our application looks like. And on this side, we have a thing called Forge, which is the Firebase debugger. And it effectively allows us to see what's happening within our Firebase. Now, this is also real-time as well. So any changes that we make within our user interface, like if I change this to, I can't do that, can I? If I add a new card, I'll add a new card saying, we add a card for Ray, and over here we've had our update to our Firebase. So effectively what I could do now, and again I've got very little room on the screen here, so I could change this to be a random avatar. I'm hoping it's a guy, not a girl. So I'm going to change the avatar that's being used for Ray in this card here. We'll scroll that up a little bit. And I'll change that to avatar number 3. And that's changed it for Ray. So now we have real-time communications between Firebase and the application. And Polymer is able to show these events changing in real time. And other things we could do is change this to awesome. Oops. And you see the changes in real time. So this is all happening within the Firebase itself. It's very, very easy to go in and see what's happening with your data. As I say, we don't have much room on the screen at the moment, so it's not that effective. But you can also do things like, with this application, you can set favorites. So you can check that, and you can go and see that this is now set to true. Or I can set that back to false, and we no longer have a favorite. So they're wired up completely dynamically. Every change that's made to the user interface is immediately reflected in the Firebase, and every change that's made in the Firebase is immediately reflected back in the user interface. Now obviously this application would also need to work offline as well, so I believe it has offline capability as well. So you could make these changes, they wouldn't be synchronized immediately to the Firebase, they'd be stored locally, and once the connection is made back to the Firebase, the data will be synced out. You may also get new stuff coming back in from the Firebase as well, stuff that you're interested in. So maybe somebody else has added new cards that you've not seen. Your cards will be synced to the Firebase, and other people's cards will be synced back to your application. And that's how it works. Pretty straightforward. So back to the slides. But getting started is pretty straightforward, and you have pricing plans, but the best pricing plan to get started and kick the tires with Firebase is the Hacker plan. The Hacker plan is free. You get your Firebase and you can use it immediately. You get limits, of course, to what you can do, but it means you can play with it completely, test out all of the functionality. So it's very, very easy to get started, and I can kind of show you that, I think we have time. Again, I can't see much in the URL bar. So you create your free account. I've already got an account on here. For some reason it's not letting me log in. Why is it not letting me log in? There's no login button. Where's my login button? It's probably gone to the screen because it can't see it. Hard to say. There's my login button. You love dynamic responsive apps. So I can sign in here, and I'll go back to where am I going to go to? I have a 5-minute tutorial. I can get up and running very quickly. I need to log in again. That's one annoying thing about the user interface. But basically, here's my Hacker plan Codemotion demo Firebase, which I've set up. I can manage the application by going into Forge. I can upgrade at any time to a paid version of the Firebase. So we have a couple of plans, I think 3 in total, and there's also support for enterprise as well. So if you're an enterprise customer and you're interested in using Firebase, they've got you covered as well. So going back to the slides. So what's next, effectively, with Firebase? If you haven't tried it, you probably don't care. You probably just want to get out and try it anyway. But we're doing some interesting things with it. So it supports queries today. So it has a rich query mechanism that allows you to query your JSON objects, your data that's actually stored in JSON by child or by key value, that kind of thing. So it has very powerful queries already. And there's a good article on the Firebase blog regarding that. The offline support isn't perfect across all of the platforms yet, so they're working on making that better. Also, improving user management. I mean, it's really extensive as well already. It's rules-based, effectively a DSL written in JSON, so you can declare all of your rules for your user management and access to data very, very easily. But they're making improvements to that as well. And finally, integration with the Google Cloud Platform as well is another key thing that's in progress. But again, they've only been part of Google for 4 weeks or so, so that's not really moved forward too much so far. But they have this thing called triggers. So triggers, on the left here we see our mobile device, our smart client, talking to a Firebase, syncing bidirectionally with a Firebase. And what can happen if you can define a trigger to say when that data changes, I want you to fire off another event to something else, effectively to a webhook. So once the data changes, you've registered a trigger, which is the webhook effectively, that will be called, and whatever's hooked onto the end of the webhook will be invoked. Now it could be another web application, it could be something like Google App Engine, it could be Heroku or anything like that. So effectively you can handle the trigger in any way you like. In this example, so the trigger, the webhook itself will contain information about the data that had changed, the location of the data, the values that are changed, and you could act on that data in certain ways. In this example, we're seeing effectively doing reporting on changes that are made to the data. So every time the data changes, one of these triggers is fired off to Google App Engine. App Engine does some pre-processing and it stores the data into BigQuery, which I mentioned earlier, and that allows you to perform analytics across your reports. So you know you can actually look at the changes and do kind of auditing across all of the changes that have happened within your Firebase. So that's one simple example of how it can be used. And that's what a trigger would look like, again, using this DSL type format for declaring stuff within Firebase, rules, that kind of thing. We have a trigger here defined, we have certain criteria, we have the webhook definition, which is a post request to my.externalservice.com/endpoint and some HTTP post body. In this case, someone said hello. But it could contain much more. It also contains other information from the values that have changed. So that's Firebase. You can find out more just by going to firebase.com. Get started immediately. You don't have to pay, you don't have to put in a credit card. The hacker plan is completely free and without any kind of, where's my credit card stuff? Yeah. Just get started. So thanks for listening. And if you have any questions, I'm happy to take some. Hey.
Okay, so far it seems like the Firebase application is related to the platform as a service. Is there any way to get the Firebase service installed on premise?
On premise. We had this discussion last time when we spoke about this at DevOps, but not currently, no. I think if you look at the website on the enterprise contact sales thing, it mentions on-premise, but I don't believe they do it at the moment, so it's not an option. But I think one of the plans for Firebase is to make it ubiquitous, make it an open source standard that everybody can write to, and then ultimately have everybody implement it on-premise, different cloud platforms everywhere in the world. That's what the plan is, the grand plan. So, okay. Any other questions?
Hi. How does Firebase handle things like database locks or read-write errors as a user? You know, I want the most help as possible, and this is using some type of interface to interact with the database. So, how does that work?
Okay, so you're basically asking how does Firebase handle concurrency, concurrent reads and writes to data, yeah? Okay, so I think the guys, when they originally developed Firebase, they spent a lot of time working on how to solve these kind of race conditions where two people may be trying to access and update the same piece of data at the same time. I don't have that much information on how that's done currently. We think it's the first right wins. Is that what we said, Ray? The first right wins, or yeah, the first right will win. So if we have, it's transactional, obviously. If we try to update it from two different client devices simultaneously, the first one will win out, and the other one will be rolled back. So we're trying to find out more information. So we've only been known about Firebase for 4 weeks, but once we know more, we'll let everybody know. But don't really have all the answers yet. But it really is very, very stable and used by lots and lots of different companies.
Thanks.
Thanks. Any more questions? No? Okay. Well, so thanks for coming. Enjoy the rest of the conference. See you tomorrow.